I'm going to be tossing a couple of definitions at you and terms that are going to be really important going forward here. So make sure that you write these down. And if I say a word and you don't immediately know what it means, make sure you write it down and have it ready to go. So, first one is a midpoint. And I alluded to this, I referenced this earlier this week and said between doesn't necessarily mean that it's exactly in the middle, because now we're talking about exactly in the middle. So a midpoint is just a point in the middle. And so in this diagram, it's going to be that point M right there. And we're saying that it bisects the segment, dividing it into two congruent segments. So I want to talk about each of those terms and make sure that we know what they mean. All right? Bisects, we're going to talk about this more in the next chapter, but bisects just mean splitting in half. And the reason we'll talk about that is because when we talk about angles, angles can also be bisected. We can split an angle in half as well as a segment in half. In fact, we'll call splitting an angle in half an angle bisector. So it'll be important to know that word as well. And the other word that's in here that you might not know is congruent. Congruent means same measurement. Congruent just means they measure the same. And we use that to talk about all kinds of different geometric shapes or figures. So anything that we can measure, we can compare them and see if they're the same and say that they're congruent. So right now we're talking about segments being congruent. We'll eventually talk about angles that are congruent. Eventually in a chapter we'll talk about entire shapes and how to say an entire triangle or a square is congruent to another square. But it's going to stay the same meaning. The meaning is going to be all the measurements being the same. So that's going to be our definition of congruent. And the symbol that we're going to use is going to be an equal sign with this little swirly over it, the little tilde, if you take Spanish. So that is the symbol for congruent. Those are our three words that you need to know. Midpoint, point exactly in the middle, and that's going to make the segments, splits it in two equal pieces. And what I mean by splitting in half, another word we use for that is bisecting. That's less important for now. But the main one is going to be congruent. Congruent means we have the same measurement. So those are words, make sure that you know them. And so to put all that together, we can say that if we have a midpoint, that the two pieces are congruent. So we're going to say segment A to M is congruent to segment M to B. Because remember, if we have a segment, we put a little bar at the top. So there's A to M and M to B. Those two segments are congruent, and that tells me that they have the same measurement. In the diagram, we mark that with these little tick markings right here. So tick mark there and tick mark there. To tell me that in the diagram, that they measure the same. So sometimes you won't even be told that they're congruent over here in this bit of information, but the diagram will have these little tick markings. And you'll need to know that that means that they're congruent. So in other words, if I tell you that A to M is 5, then you should be able to tell me that M to B is going to be the same, that it's also 5. And of course, the whole thing is going to be 5 and 5 is 10. That's what we talked about earlier this week. So that's the idea of the segment. We're not just splitting the segment up somewhere in between. We're splitting it exactly down the middle and the two pieces are going to be equal. This is going to move around in a second, but here's A, here's B, here's the midpoint M, and so here's the segment. And you'll notice these are congruent. And I'm going to move these around so you can see how the point changes when the midpoint, how the midpoint changes when the point changes. So this point right here is staying the midpoint. It's staying exactly halfway in between my blue and green point, where it's more of a purplish. So that's split exactly into the middle, so it puts it into two equal pieces. So that's a useful bit of information for us because a lot of times we want to know if two measurements are the same. And so knowing that something is a midpoint is going to help us do that. So let's look at some examples. I'm going to do two examples today, and that's going to be it. M is the midpoint of the segment. Draw and label a diagram, and then find the length. So what we're going to do is we're going to draw our diagram. M is the midpoint. We have A and B on the ends. Here's A. Here's B. And we're still going to put M in between it, but now we're going to put M exactly in the middle. And then we can label the pieces that we have. A to M and M to B. A to M is 2x plus 35. So that's our distance from A to M. M to B is 5x minus 22. So that's this piece here from M out to B. And what we know is that because M is the midpoint, those two pieces have to be the same. And so we have this 2x plus 35 and this 5x minus 22. We know that those two have to be the same. So we're going to set them equal to each other. In other words, here's the marking we can make in the diagram. Or we can say segment AM is congruent to segment MB. Remember I said your equations should always be grounded in the geometry in the diagram. If you're setting these two things equal to each other, you should be able to point in the diagram and tell me, here's how I know these two are the same. Let's solve the equation. Let's move these to the other side. So we're going to subtract 2x. Get everything with x on the same side. So I got 5x minus 2x is 3x minus 22. Now I'm going to add to both sides. I'm going quick because if you need to pause and go back, you can pause and go back. And then I want to divide to get rid of the multiplication. Divide by 3 on both sides. So that means we're going to have x equals 19. So 19 is our answer for x. Then, to find A to B, again, if you're not ready for that yet, you can pause and go back. To find A to B, what we want to do is remember last time we double-checked our answers to make sure they were working out the way we thought they would? So we're going to use that to figure out what A to B has to be. So we know that A to M. These two should be the same if we did it right, because the pieces should be equal. A to M is the 2x plus 35, so it should be 2 times x is 19 plus 35. 2 times 19 is 38, and 35 is going to be 73. And then M to B should work out to be the same, hopefully. That is 5 times x is 19 minus 22. That's 95 minus 22 is 73. So that's how we know we have the right answer, because these two work out to be the same. Now, we know this is 73, and this is 73. And so then we can go on to say, that means that A to B has got to be 73 and 73. The entire distance from A to B has got to be the two pieces put together. That's what we talked about all this week. So that's going to be 146. This next problem I'm recording later because I realized that there was something wrong with the example. So we're going to change it. So pay close attention here. This minus, I'm going to make it a plus, because otherwise it didn't solve very cleanly. That minus is a plus, so now it's x plus 52. Let's draw the diagram. Here's A, and here's B. And I'm going to put M as my midpoint. Remember, midpoint means it goes exactly in the middle. So those pieces are going to be the same. They're going to match. And now we're going to label those pieces. So we have an x plus 52, change it to a plus, x plus 52 for A to M. And then this part's a little bit different, because we're not given the other piece, we're given all of A to B. All of A to B is 3x plus 6. So this entire distance from A all the way out to B is 3x plus 6. So that's going to change the equation. Remember, your equation should be based on the diagram. So if you're setting them equal to each other, I'm looking at that diagram, and I'm going to tell you, well, no, they're not equal. This one's obviously way longer than this one. This entire thing has to be longer than its piece, so they can't be the same. So don't set them equal to each other if they're not equal. So what do we do? Well, what we're going to do is we're going to use what we know about a midpoint. Midpoint is going to make the pieces the same. It's going to make the pieces match. So by that, that means that A to M and M to B, these pieces are going to match with each other. So if this is x plus 52, remember in the beginning I said, hey, this piece is 5, so that piece is 5. It matches. Same thing here. This is x plus 52. That means this has to be x plus 52. They've got to match. And now I can set up an equation just like I had set up at the beginning of this week, where I've got my pieces that match, and I've got the whole thing. So I add up the pieces to make the whole. So we're going to add the pieces and have it equal the whole. The whole thing is 3x plus 6. And then my pieces are both x plus 52. So I have an x plus 52 here and an x plus 52 here. And I'm going to add them together to get a 3x plus 6. And the key there is that since I didn't know what M to B was, I just made it match A to M, because I know that because it's the midpoint, it's got to match. And now let's solve. I'm going to go a little bit quicker. If you need to pause and go back, then pause and go back. X and X is 2x plus 52 and 52 is 104. So remember, put the parts together on the same side, the terms that can go together. We're not moving anything around yet. 3x plus 6 is going to still be 3x plus 6. Now we're going to bring things so that x is on the same side. Subtract 2x. So I've got 104 still here. Equals 3x minus 2x is just 1x plus 6. And so now to solve for x, I'm going to subtract 6. And then x is going to equal 98. And this time it wants M to B. M to B is this piece right here. So it's x plus 52. So I take 98 plus 52, and that'll be 150. Last one I want you to try on your own. It asks for x to m. I will tell you so that you can check your work that for x to m, you should get 63. When you plug in for x and get that length back out, you're going to get you should get 63. Once you set up the equation, draw the diagram, solve for x. Don't just write 63 for this problem and be done. I'm taking points off of the notes if you do that. I want to see that you tried it, that you checked it, that if there's not something right, you're asking me about it, and get that answer back. So those are the notes for the front page. We're going to do the rest on Monday and Tuesday, so I'll see you then.